We are researchers from University of Illinois Urbana-Champaign. We are glad to share our paper, Situational Awareness Matters in 3D Vision Language Reasoning. The key motivation of our work stem from the observation of human intelligence. Compared with machine learning models, humans put themselves inside the 3D world and then perceive and interact with the surrounding environment from their ego perspective. This capability is called situational awareness. More specifically, situational awareness marks the ability of an intelligent agent to ground itself in a complicated 3D space. This intelligence is a crucial difference which separates 2D and 3D visual reasoning scenarios, and a key to achieving seamless understanding of spatial concepts in more complex real-world environments, which is also known as spatial intelligence. However, our preliminary evaluation reveals that existing methods lack such situational awareness, which leads to false visual reasoning results in many scenarios. As shown in the top row of the figure, an inaccurate situational understanding results in wrong question answering. In light of this, we propose SQA3D, a situation-grounded vision language model, which significantly improves both situation estimation and visual reasoning performance, as shown in the bottom row of the figure. SQA3D adopts a sequential architecture to first ground situation with language description and then conduct situation-guided VQA. Given an indoor 3D scene together with language-described situation and question pairs, our model starts from a tokenization process by leveraging pre-trained frozen vision encoders and language tokenizers for separate modality inputs. In the next step, we ground the situation vector in the 3D scene tokens with the guidance from situation tokens. However, we notice that direct vector regression leads to poor performance due to the substantially large 3D search space. As a result, we propose to effectively reduce the search space by treating each token as an anchor point and query the situation tokens to predict a token-level position likelihood and rotation matrix. With this anchor-based method, our method achieves more accurate localization of situation vectors associated with the text descriptions. Additionally, we update the visual scene tokens with situational position embedding and a situation-guided visual re-encoding with a shallow transformer layer. This process guides our model to focus on regions that are more relevant to the situation description by switching to the agent's ego perspective. Finally, we use a large language model decoder to conduct 3D vision language reasoning task in the form of visual question answering. Evaluations on two challenging datasets, SQA3D and ScanQA, demonstrate that SQA3D achieves leading performance in both benchmarks and in both situation estimation and VQA tasks, as demonstrated by the three tables. Additionally, our ablation study reveals some intriguing features of our proposed method. First, as shown in the left table, our architecture supports various vision encoder and language tokenizers. And also, we demonstrate in the right table that all of our proposed modules, including the modules for situation estimation phase and modules for better utilization of situation estimation, contributes to a better situation understanding. Visualization of visual token activation before and after situation re-encoding is shown in this figure. This visualization employs the Veritas color map, where a brighter token representation indicates a higher activation value. The effectiveness of situational guidance in amplifying the relevance of crucial tokens is evident from this depiction. For instance, the visualization in the first row reveals a notable shift in focus. Initially, the tokens predominantly concentrate on the bed area. However, post-re-encoding, there is a discernible shift in attention towards areas closely aligned with the situational vector and those directly related to the query. To conclude, in this work, we recognize the lack of situational awareness as a major oversight in existing research and demonstrate its significance in 3D visual understanding tasks. We introduce our model SQA3D, a situation-grounded 3D vision language reasoning architecture to insert spatial intelligence to visual language reasoning models. Finally, our model demonstrates superior performance on two challenging benchmarks and different reasoning tasks. Please scan this QR code to access our project page for more details and demos. Thank you very much for listening.